morning, good evening, good afternoon, everyone. My name is Richard Lydon. I'm your panelist and moderator for this session. And just to start with something with our mission, a mission for WFI, we believe that education is the first step for people to gain the knowledge, creative thinking, empowerment, and skills they need to make the changes to extraordinary lives and to make this world a better place to live. And with the joint efforts from our advisory board members from 12 different countries here we have 40 experts and advisors here in front of you on this slide. Next one, Christine. Sorry, just one moment, sorry. Together, we're proudly supporting the industry with the most comprehensive, practical and cost-effective and time-efficient education program. And on the screen here, you can see the certified filtration and separation specialist program we run on areas such as global filter media, global filtration market, filter media markets and technologies, air and liquid filtration technologies, air and liquid filter design, air and liquid filter testing and evaluation, and new development opportunities and trends in filtration. Last Tuesday, we had our first for the year CFSS 2023 opening ceremony. It was overwhelmingly attended by over 200 people. The topic on the screen, global filter markets, outlook and opportunities and trends, was discussed in great detail. We received many questions from the audience, and with this filtration hour, this first ever filtration hour we're holding, we're going to address some of the received and opening questions we had. So here's our panelists for today. All members, I think, bar one, are on our advisory board. We've got Kathleen Owen from ASHRAE fellow member. We've got Dr. Thomas Peters from Peter Consulting in Germany. We've got Tyler Smith from Johnson Control, Bruce Larange from HMV, Steve Nichols as a NAFA past president, myself, Richard Lydon, from the Filtration Society here in the UK, Dr. Ayad Al-Attad from Cranfield University and also works in the Middle East. We've got Christine Dunn, who's our host for today, Bob McIlvaine from McIlvaine Company, a long time in filtration, and Mitch McCreevy from WFI as well. So with that, we'll probably start with some questions we've already received last Tuesday at our opening ceremony. We have 8 questions here. We're very welcome to take questions during this session as well. So if you have any questions, just send them through the Q&A, and today is all about having a conversation about filtration. So the first question here is one of the most important topics. We talked about protecting the environment with filtration is how we dispose of it properly or recycle in expired use or clogged filters. Do we have any thoughts on this? So I'm going to open up this to the panelists. And I'm wondering whether, Bob, you would like to start the discussion on this in terms of just any thoughts on recycling, cradle to grave, the whole area of how we think about filtration, the materials we use, and protecting the environment going forward, especially in the context, I think, now of more consciousness about filtration in general.
Yes, we've done some fairly deep studies, including one for Cardinal Health. And it happened to be with single-use disposable garments, but reusable for surgical purposes. It's $1 billion industry. And we spent about 6 months on the question, and our conclusion was that the fuel value of filter media, synthetic filter media or gowns or whatever, is about 20,000 BTU per pound. And the average waste energy plant has to supplement the fuel with natural gas due to the poor fuel content. So it's only a few thousand BTU per pound. So the bottom line is the more of this that goes into a waste energy plant, the better the environment. And it's so it's a default choice. And even if it's after 3 or 4 uses, that's extremely beneficial to the environment.
Okay. Thank you, Bob. Ayad, have you any comments on this?
I think it's. I have a question, a comment regarding the disposal before we think of the recycling. So I'm just one step ahead a little bit. Is the way we dispose it from, let's say, the hospital back to the area where we need to think of recycling. I think this needs a lot of attention. I've seen this in the past 24 years where a lot of HEPA filters, for example, they're taken out of the operating theater and put on the hallway or the corridor or the basement, let alone some parts of the developing countries. HEPA filters are washed with compressed air, water being dried, put back in the system. So I think there is a lot of awareness that needs to be provided in terms of how risky or dangerous having a loaded filters in the first place to be handled. I don't think this sort of awareness exists, certainly not in developing countries. So there is a lot of sort of back to basic principle homework we need to get done.
Yeah, I'm also wondering just a little bit, and not to spend too long on this, but I'm wondering also about the fact that maybe we don't think of this as a disposable consumable at the moment. For example, you know, if we go back 40, 50 years, we used to dump car parts. We used to dump, you know, white goods. We started dumping first our mobile phones, but now, because they're all made of special minerals and materials that we all require in the future, they're all recycled, or most of them are recycled again to be recycled. So there is a cradle to grave philosophy around starting to come around consumable goods. And I'm just wondering about industrial products. Will this happen in some context? And maybe that's kind of the thought process here, I suppose, that maybe we need to think about in terms of this first question. Bruce, do you have any thoughts on that in terms of just coming from an air perspective?
Well, I would just add, I think that this is, you know, a great starting point for thinking about where our products end up as an industry, and the fact that increasingly we should expect, and we are seeing, that consumers care about not only what's in their products, but what happens at the grave stage. So I think that that's a positive application towards thinking about what we're putting into our products. Obviously, life cycle assessment is becoming more important. We see that with the creation of air filtration. You know, even with our medias that we're manufacturing, we're trying to think about more sustainable fibers. And so the fact that this is a topic, I think, in and of itself is important, because it's really forcing the industry to think about what we're putting into our products and becoming more transparent, so that we can be responsible not only with the creation of products, but where they will end up when they've served their useful purpose.
Yeah, that's a very good point, Bruce. Mike, you've got your hand up. Yeah, please comment. Yeah, thanks.
Yeah, I'm just wondering about whether we should be thinking about this as the final customer being human lungs and the product being clean air as opposed to filtration. And what can we do to reduce or divert? Are there other methods, non-material, electrostatic, molecular, diversionary, that kind of thing, that we should be putting as much effort into as we do filtration materials?
Okay, good point. There is also a question from Fahd in the audience. I think there is a serious problem on environment with secondhand equipment containing different types of filters. Does people have any thoughts on that? Ayad, maybe?
Richard, would you like to allow the participant to say the question, or maybe next time?
They've typed it already, so I'm just trying to think about the answer. Yeah. Thank you.
I'm not sure if I can, if I fully understand the question, but you know, when it comes to acquiring filter, and it's, you know, again, it connects to the same point. When we address filter performance, air filter performance, then we add the buzzword, sustainable air filter performance. Where does the sustainability part end? Does it end after we take the filter out? So basically the filtration manufacturer doesn't have any specific recommendation how we dispose the filter. But in fact, I think there is also a maintenance issue. And we've talked about this before. I don't think the investment in certifying, training and retraining the technicians I don't think this is something that has been looked at. I think we need to invest in this. Of course, if the question is about contamination, maintenance needs to be revisited, because if you take a filter out and replace it with the new filter, this does not mean that you've done your maintenance homework.
I think the question is geared towards secondhand or used equipment containing different types of filters. Now that often is the case, that you will have maybe some new filters, some used filters going into application. That's quite common in those situations, I think. There is a serious then environmental problem in terms of if those filters are not disposed of correctly, or if those filters are not handled in the correct way. I think that's the key issue here. So, for instance, if they have some contaminants on them, then that, like soot or other harmful contaminants like heavy metals, or any other materials on there that needs to be disposed of correctly, then they can cause a serious environmental issue. I think the other thing I think around this question is perhaps the whole area of thinking about recycling of materials. So I think we've grown up with that with the culture of polymer materials as being the default material. But biomaterials are coming more and more into play. And I'm just wondering, could we spend a minute or two talking about biomaterials and maybe that area? And I don't know whether Mike or Bruce, maybe you can touch on that in terms of just the trends maybe in the marketplace there.
Yeah, certainly. I mean, I think so I'll touch on that, but I did want to just add a point, and then I'll get to the biomaterials, which is related to properly disposing of a filter, and also how much you're putting into the environment. So perhaps better performing filters that have longer lives is another way to minimize the impact societally of the filter being disposed. And that does lead into bio fibers as well, largely because we know, for example, in India, where you're seeing crop burning of wheat straw is a significant pollution source within the country. I know in other industries, for example, packaging with cardboard, Dell computers, for example, is actually harvesting wheat straw that can be used in their product packaging, and it's not only helping as a fiber that's more earth friendly when it is disposed of, but is also taking out a source of pollution in the environment. So I think that looking at these sorts of opportunities, which aren't just about improving the greenness, if you will, of the materials going into filtration, but also thinking how you can mitigate the amount of pollution that's happening as a total ecosystem is important. And certainly there's more focus on that at the R&D stages right now.
Great, thanks, Bruce. Yeah, Tyler, did you have any thoughts on that? Because you come from Johnson Control, and I know there's a lot of work going on in that field as well. Do you want to just unmute yourself? Yeah, thank you.
I actually don't have anything accretive to add to what Bruce just stated. I think you summarized it pretty well.
Okay, great, thank you. Yeah,
yep.
Okay, wonderful. Okay, I'd like to just move on to question 2. If we all believe that IAQ is so critical to health, why aren't there more regulations or enforcement of industrial standards? Maybe we start Kathleen with you on that one, because of your background in this area and your in the sector, and especially with regard to regulation. Maybe you can talk about that for a minute or so.
When I saw this question, my first thought was to think about how far we've come in the time of my career, to kind of give a perspective for why we aren't farther now. But I started working in this general field in the 1980s. We were filtering to keep coils clean. We were trying to keep outdoor air from having stuff that was big enough to see falling on our cars from being a problem. We wanted to be able to see the mountains one layer over. Since then, we have moved from up to MERV 6, MERV 8s for pre-filters. We are putting air filters in to address breathing. We were not doing that when I started. We have had PM10 regulations outdoors that have been so successful that we've been able to see the effects of PM 2.5. We are now doing regulations outdoors on PM 2.5. With COVID, we have been looking at how do you filter out pathogens. Yes, we probably do need to get more regulations, and we certainly need some more enforcement, especially in terms of things like knowing if your air cleaner or your filter is working right, or making sure that people are sealing things in. But from my perspective, we also have to kind of celebrate how far we've come. And the big thing there is that regulations always lag the science. It takes a consensus of people that aren't us, the people who aren't the scientists, coming together to say, not only this is what we need to do, but here's how we're going to write the words. Here's who's going to be in charge of it. So much of it is finding the right home for it, and then finding people who believe in it that aren't generally scientists to get the politicians to move or get the building code people to move. So it's complicated, but celebrate the successes we've had and hope that we get to continue having them. And be thankful we have CARB leading the way is one of my things. I was talking to somebody yesterday, how many of the things that we didn't think we'd be able to do 20, 30 years ago that we have gotten out. Now, sometimes people say they rush too fast or they get things done that other people might not need, but somebody is out there breaking barriers and trying new things. So I would love to see more ASHRAE people being able to work on writing standards, I mean, legal standards, not just 62.1 and 62.2, but I don't know that most of us want to say get into politics. Per se. So it's probably way more answer than you wanted, but yeah, it's
interesting when you think about
complicated.
It's interesting when you think about the regulation, enforcement, legislation, and then the standards, and also I suppose from a point of view of innovation has come on a long ways in the last I would say in the last 10 years. Tyler, do you want to just have
I would love to
on that?
Yeah, thank you, Richard. To add to Kathleen's good points, I think it varies globally, pretty substantially globally. It's going to take all of us, and it's only a matter of time. I am really energized by what Kathleen said, not only about how far we've come, but the forcing function that COVID was to really pushing this conversation into the mainstream and into the likes of the groups of politicians and concerned parents and other stakeholders here that are now accelerating that conversation even further. In fact, yesterday, we got some really exciting news out of the EU, thanks to lobbying efforts by Johnson Controls and other institutions, that the Energy Performance of Buildings Directive, EPBD, in the EU has now been amended to require indoor environmental quality, including IAQ sensing, for buildings on their path to net zero energy. So I think we're gonna, for the next several years, see pockets of success like that globally. And then that momentum will carry us to a super exciting place over the next 5, 10, 15 years.
Yeah, I think you're very, very, very prudent to say that. It took a pandemic to alert us to air quality in a slightly bizarre way. Okay.
Yes.
But just before you came on, I was just having a quick chat with Bruce about IAQ and IEQ, and I'm maybe just hand it over to Bruce on this one, just in terms of maybe trends, environmental trends. So we're moving towards buildings that are much more airtight, that are much more energy. Energy is the next one that's going to drive now how buildings operate internally, globally, at least in Europe, UK, continental Europe, Scandinavia, etc. There are very tight regulations on buildings. No longer have we got leaking windows and doors and air. We're talking now about air movements, as you alluded to, Tyler, in your talk as well a week ago. But Bruce, what's your thoughts on this in terms of trends, the environmental side, and how maybe we think about the education of this as well? I mean, there's a bit of work that has to be done by us, the industry, and people are involved in this, I think, as well.
Yeah, and great comments by Kathleen and Tyler. And to expand on that, first and foremost, education, I think, is the key. As we all know, and we've discussed ad nauseum, the double edge of the of the pandemic was that it did start to get people thinking more about the air that they breathe. Obviously, when you're in the built environment, in many ways, we're sort of goldfish that are often swimming in dirty water, but we can't see that water. And so we as a general public haven't been that aware of the air quality. So sensors is where the logical conversation goes. It's exciting that with the advent of more readily available sensors and so many entrants into that space, that we're starting to measure more in buildings. Obviously, the more widely adopted that becomes, the more attention that will bring to air quality indoors, which is a great thing. So as we see the increased usage of sensors, that is one critical thing that should be driving trends. The other side is on the education side. It's easy for us, mostly who are on this call, understanding filtration, understanding how public health is impacted by air quality, to approach this from a very logical standpoint. But there's such a gap between what the general public understands and sort of the onus is on us in the industry as being passionate, as influencers, as experts, to really simplify and help promote the importance of air quality for better health, for better productivity. And so there's a lot of opportunity there. I would just, and then open this up to other panelists and potentially even anyone in the audience. But I think that the focus is what's important. There's certainly efforts to have legislation. Those are timely. There's things that are stuck right now in Ways and Means Committee that are bills that are moving. But I think we can move quicker as an industry by creating a coalition to educate and really help the public understand what's happening, getting sensors into buildings, and just getting more focus and attention on air quality as a public health threat. So I would certainly invite anyone else's comments there on how we as an industry could educate and better bring attention to this as a significant problem for human health.
Yeah, good points, Bruce. Yeah, Mike, you've used your hand up. Just hand it over to you for just a moment. Yeah.
Yeah, just to follow up on what Bruce and Kathleen said, this is not really a scientific problem. I think everybody here knows how to get MERV 13 into commercial buildings, into residential buildings. It's really a matter of what we need are evangelists, as Bruce mentioned, and we need lobbyists, as Kathleen mentioned. You need to be able to put this into regulation, have that visibility, the sensor visibility on a larger scale. It's got to be part of an IoT sensor network where you can have effective regulation and enforcement. Without that, I mean, you think about, what other voluntary, participatory mass movements are there when it comes to an invisible process that's actually going to cost a little money. That's where I think we've seen filtration industry move ahead in a lot of ways, is when you have the requirement from governments. And I think the other thing to think about there, that assumes that you're talking about people in the West, with strong civil society and with governments that are capable of doing that. And probably the majority of the world's population doesn't have that. Completely different challenge.
Very true point. Yeah, that's the same for air as in water. It's the same problem globally. Yeah. Ayad, you got your hand up as well. I'll let you in on.
Just very quick comment, since we've mentioned standards. I know standards are important. Maybe we don't have the best ones yet, and our grandchildren is going to laugh at us when they see the sort of standards we're using today. So I wanted to mention is standards right now are barely followed or poorly followed, and maybe poorly misunderstood or understood. So I think what we need to be looking at is why do we have a lot of standards and filter failure is quite common. I think what we lack is the awareness. What we lack is basically bringing the filtration knowledge to the audience, make it available, make filtration performance sustainable. And I think this is where I can bring in WFI to play a major role in doing this. Part of it of what we're doing today, discussing and sharing knowledge with and from the audience. So I think air filtration and air quality barely gained any political traction thanks to the pandemic. The pandemic basically shed a lot of light, put a lot of hype on filtration, which may not be necessarily the only solution, because there are other aspects in terms of heating, ventilation, and air conditioning that have to do with the built environment. I just want to say something very quickly, is that in the past, we were focusing on what the built environment can get from filtration. So what are we getting from filtration? I think it's about time we think, what is the built environment can be becoming from using professional and deploying professional filtration technologies.
Tyler, you had your hand up as well. Just the last point, I'll go, and then I'll go to the questions in the panel in the audience. Yeah.
Thank you. Just to put a very fine point on this, and I think Bruce used the word simple or simplify. I think that's where the opportunity exists for us. We've got all this data. We engineers on the phone understand what the data mean, but how do you connect that to the layperson? How do you connect that to the person who we need to understand and care and advocate and raise their voice? So the simplification and the communication of indoor air quality data and the so what behind that data is absolutely critical to us crossing the chasm here that we're all talking about.
Great. Just some questions then from the audience. Could you provide some thoughts about how best we can benefit from air filtration in eliminating bad smells? I think this is coming from the surrounding environment, especially when facilities is located close to an area where there's poor air quality, such as oil and gas or industrial intense areas. Please provide some examples of and I suppose this is kind of where you're looking at air quality next to a built-up environment where those two have to cohabit or coincide. I don't know whether somebody wants to take this, and there are many places around the world where this I think this exists. We had that example recently, in the US, with the train crash, etc. But that was a pollution issue. But similar issues exist day to day with with oil and gas plants, chemical plants, with manufacturing plants next to residential areas. Any thoughts on that from anyone, Bruce or anyone?
Happy to take the first crack at this.
Okay, go on, Ayad. Yeah.
2 points very quickly. One, this always requires or takes us to the initial point, that is physical and chemical characterization of the outdoor air, where your application, whether it's a hospital, a shopping mall, whatever it is, get to know what you're up against. You have that characterization, then you go back and speak to the HVAC equipment and the filtration and say, these are the gaseous contaminants that's challenging my built environment, and these are the particulates. This is the characterization. This is the way to do a professional homework. Otherwise, it's just an over-the-counter solution, going to the pharmacy, buying a headache medication just because you think you only have a headache. Again, to go back and to be a little bit harsh on air handling unit manufacturers, why, when we examine a common AHU, we only have sections for particulate filters? Where is the place for sorbent, for gaseous filtration? I think this needs to change. It needs that we revisit the issue, but this is basically the homework we need to do on the characterization part and on your part as bringing the outdoor air indoors.
Any other thoughts on that? Bob, do you have any thoughts on that in terms of just outdoor air quality from manufacturing companies in terms of the smells or the air or the gas that may come from those plants?
Yeah, we have a whole service in that area. And for reference purposes, there are more complaints from the public about odors than there are about particulate. Municipal wastewater treatment plants have spent a lot of money, but it's very difficult because you're talking about parts per billion that generate the odors. So things as elaborate as odor panels and so forth have been employed to try to determine even what the quantity is or the effect is. So it's a very difficult problem, but one that a lot of money has been spent on.
I agree with you there, Bob. I mean, for instance, if you talk about ammonia or methane that's coming off wastewater treatment plants, it's quite considerable. And there is a lot of technology now that's going into those plants, especially if they're located close to, built up environment. I think the other thing is, there is, of course, large industrial areas with oil and gas and chemical and other types of processes. I don't know whether or not somebody else just wants to mention. Bruce, do you have anything on that? Because H&V does quite a little bit of work on off gases and things like that, I think.
Yeah, I mean, and there may be others that can speak to the technical aspects of the product better, but certainly absorbent material and molecular filtration is an increasing focus. And a lot of focus has been put on particulates, as we know, in PM 2.5, PM 10. So this is increasing, but I mean, my comment would be, less to the technology that's needed and more to the application of it. And the reason is, if you're in an adjacent building, for example, to where there's a problem, a big issue isn't just having the right technology and the right solution, for which there is one. It's, is that solution being employed to actually protect occupants in nearby buildings? It's the exposure piece. And I think that touches on previous questions and comments we had around this misalignment, which is that, is there a focus, the people who are paying for filtration that can protect you, whatever, as Iyad had said, related to, whatever that problem is the right solution going into a building, and the people paying for those solutions are quite often not those who are benefiting from the clean air that they provide. So there's the problem of identifying the issue, having the right filtration. Molecular filters are increasingly being requested, but then there's also the matter of, are they being employed correctly? And I think that's something we should be aware of. That's still a major problem, not just having the solution, but making sure it's widely available to those who would benefit from it.
Great, thanks, Bruce. That's very good points there. Kathleen, I'll hand over to you, and then Mike, just for final comments on this. I know, Kathleen, from an ASHRAE point of view, you must have some thoughts on this. Yeah.
Oh, I'm one of those people at ASHRAE that sits in both sets of meetings, the gas phase and the particles. The first thing is, even though it's been kind of inferred, smells are gases, not particles. I mean, the discussion has addressed that, but not exactly saying that. Sometimes particles that are caught can give off gases that smell. But to me, the first place that we need to look at is, where is the smell coming from, and source control. And that's Kathleen, the engineer from, not the MER filter lady. One example that I've heard of a good bit lately, last 5 years, is cannabis and marijuana production places that the neighborhoods smell bad. There's a lot of work going on for how do they do cleanup so that the air coming out of the plant doesn't stink. This is the first level should be not doing the process that smells bad in a place where the air can get out. Second one is controlling that air. So that doesn't work for every place. In many places, they've already done as much as they can. So then, yes, you need to look at what you can do in your building. But I want people to think there's many different steps on dealing with this problem. Another thing, though, like wildfires, which have been a big deal lately, that's an odor issue that we can't control per se anyway. But we have test methods for sorbents and some of the other air cleaners. We are working on more of them. We need to get groups to figure out more ways to put information together that people can come and find and figure out what they need for their environment. We also need to educate people a good bit on odor thresholds, because if your goal is to get rid of the smell, not to reduce a compound to a certain level that's non-toxic, say. I mean, try to do both if it is toxic, but a lot of things that smell aren't particularly, they just stink. We need to realize that what we're doing is peak shaving. It's not necessarily you have to get rid of everything. It's that you need to keep it low enough that people aren't complaining. So that's an education thing, because it's very different from particles. Your sorbents work, for example, usually really well to start with, and they get less efficient over time. Particle filters often get better. Sometimes they get, anyway. So there's a lot of different issues, but the gas phase is behind the particles, and I would say that will probably be one of the big issues the IAQ community will be dealing with, and we are working as hard as we can to get good information out to people.
Great.
As we get it.
Great, thanks, Kathleen. Mike, you had a thought on this as well?
Yeah, I was just going to say real quickly that I think we can take a look at the alternate indoor air quality community in cabin air, in vehicle cabin air. where this is really it's a selling feature, because you can't say your vehicle is never going to be in these situations like you can a house, right? And so that's given tremendous acceleration to the idea. It's put, people talk about this because of that. I think, the more we see sophisticated HVAC in cars, specifically in electric vehicles, the more people are going to think about that for their homes and demand it.
Okay.
To put this in some historical perspective, probably 40 years ago, we started getting not emails because it was faxes back then, from Asian scrubber manufacturers that said we'd excluded them and explained that Hong Kong had a odor regulation that any restaurant with 3 woks had to have a scrubber, and it had to be one that was listed in the McIlvaine scrubber directory. So that kind of gives some historical perspective here.
No problem. If at any point any of the audience want to ask a question, please put up their hand. There is another question I have here, which is from which I think it's a kind of a joint question, but this one's very interesting. So the most dangerous ultrafine particles to our health is 0.1 microns, but studies have shown that airstreams does not affect particulates smaller than 0.25. So I think actually it's PM 2.5 microns and PM 1 micron. But I think this one is talking about particles even smaller than this question. So if ultrafine particulate cannot be pulled into the filter, how can these dangerous ultrafines then enter our bloodstream and cause inflammation through the body be addressed? It's an extremely interesting one because, of course, we talked about PM10, we talked about PM 2.5, we talked about PM1. But Kathleen, maybe the ultrafine area is something that maybe we haven't even have we started to address yet? Have we started to talk about? I don't know. Maybe I'm not in this market completely all the time, but can you maybe address that?
Well, one thing that I tend to talk about every time I talk about filtration is that the different mechanisms that enable a filter to catch different sizes of particles, such that filters have a low point in efficiency, but it gets better on both sides of that minimum. So airstream, perhaps issues aside, filters will catch smaller particles. In the 10 to 20 nanometer range, you have issues because they're starting to act really like gases, but that's not the question here. But I hear often from people saying you can't catch stuff below 0.3 microns. That is just not true. Below 0.3 microns, filters often do better than they do at 0.2 to 0.3 microns. I keep hearing that there are studies that show ultrafine particles don't go with the air. I don't have like a clump of them in my house where they're sitting. They have to be going with the air, at least to some extent. I still want to read some of those studies, but I have not found them. I hadn't looked all that hard. But basically, if it's in the air, we can at least get some of it out with filtration. And I think that's the way to go. The big thing is we're still dealing with trying to get the next step bigger out. And that's an issue in my mind of the history and the enforcement and the regulation. How do we move forward to that being a critical issue instead of still working on PM 2.5? So it's a question of where people are willing to spend their money in terms of which things are getting out of the air.
Yeah, good point. Yeah, Tyler, do you have a comment on that? Because I think ultrafine technology is there. I mean, for instance, it's there on liquids. Everyone knows about membranes and that type of technology, which we'll come on to talk about in a minute. But on air, I mean, it depends how far you want to go down, I suppose, and how much we want to spend and how much regulation we need. Because of course, there's ultrafine particles all the time in the atmosphere. We're aware of that anyway. We're breathing them right now.
No, nothing to add, Richard. I think, we've got a couple of experts on this call that can speak to that better than I can, including Kathleen, who did a great job.
Great, excellent. Ayad, any thoughts on that? Because you've dealt a little bit with
just very quickly.
Nanoparticles as well, yeah.
Just very quickly, I'm not sure I agree totally that filters are unable, they may be not as efficient. But I think what we need to be really careful of is when you operate a high efficiency filter, you need to operate it at the rated flow rate. I've seen this happening a lot. When you go beyond a specific flow rate, your phase velocity will not be that suggested by the manufacturer. And therefore, your HEPA filter or your ULPA filter would not really give you the efficiency or the capture efficiency that you had expected. So operational conditions are very important. And then you need to have continuous monitoring. How else would we know how the air filter is moving? I know we're going to get into sensors, and I know we're going to get into air filtration performance toward the end of this filtration hour. But let me say this, you have to characterize throughout, before, after, and your air filter performance. I would love to go to a building and say, give me how this filter in your air handling unit has reached its final pressure drop from day one to the date that you decide to replace it, and look at it. I think that will be very interesting. It's going to require you invest in this thing, but for future HVAC equipment, I think there is no other way of looking at the built environment. We want the built environment to impress and be great, but without adaptive HVAC systems that give us data and driven by data, I think we're stuck in conventional technologies.
Okay, I'd like to just move on then. Thanks, Aya. That's good. I'd like to move on to question 3. And this came up quite a bit during, I think, the last month, 2 months as well. And it's been in the public domain here in Europe and the US for a while. With increased concerns and regulation to ban PFAS, and that's basically, for people that don't know, it's the forever chemicals. And that should be PFOS, by the way. What impact the filtration industry, as PTFE membranes are popularly used for high efficiency air filters, but also for liquid filters, actually. How should we as an industry prepare for this? Bob, do you want to have any thoughts on PFAS, PFOS, the whole area of what's happening in the it's predominant, I suppose, a lot in the water industry, of course. We talk about it a lot.
Yeah, I'd rather pass on to more expert people on the panel.
Okay, Kathleen, do you want to think about? No, you're not onto this one.
That's not a topic I know anything about, other than what I've read on or listened to on 60 Minutes.
Okay, right. Okay.
Sorry.
Mike, do you want to have a thought?
Well, from my perspective, PFAS is used a lot to improve performance of air filtration media and to provide water durability for difficult applications. You think about North Sea oil platforms with V-bank filters and that kind of thing. PFAS is important to that. I think looking at this as again an avoidance issue. What can we do instead? But I think otherwise it's a material science issue. And if you look at things like membrane, in that case, you're looking at pressure drop and energy usage as being a big part of the cost of operation. And, PFAS has, it has allowed us to do it, with glass media and some other things that we might do otherwise. But, I think it's a material science issue, and it's a race, because I think we all know that this is coming and that we have to make that change. And it's going to be a big one.
Correct. Yeah. Tyler, did you have thoughts on this in terms of nothing from Johnson Control on this? No. Yeah. Okay. Bruce on H&V.
Yeah, likewise. I think I would agree with Mike's comments. It certainly is a race. I think, if anything, it just draws, again, attention on the fact that as an industry, we have to be keenly aware of, how we're making our products and how we can advance them. There could be potentially losses to gamma, for example, pressure drop, by having to change out, materials within an existing filter or filter media. And so it really is, to Mike's point, a material science issue, and just puts more pressure on our R&D within the industry to make sure that we're delivering to the needs of the public. But I guess the positive side to the fact that we're talking about this is, again, there's going to be an increased scrutiny in our filters, as there are in a lot of products that are already out there, and it's really important that we kind of carry the mantle, take up the challenge to make sure that we're constantly evolving our technology, not just relying on existing technology that we've had for decades.
Yeah, maybe I can add some comments here. There are some concerns about PFAS and PFOS. There's been some publications recently, you may or may have read it in Nature and New Scientist, regarding the forever chemical in terms of when it enters the bloodstream, what it potentially can do. and especially with regard to, there was some discussion on this, I heard at last week also at Filtech, with regard to PTFE membranes, etc. And maybe a potential limitation of PTFE membranes going forward. And we heard at last week's event as well that some companies now are limiting the PTFE and the manufactured PTFE. So I think there is a race. I agree it's a material science issue in terms, but it's also maybe an opportunity for companies to actually, if they can address the PFAS or PFOS area through filtration itself. Yeah. Number 4, then, in what products do you see the bigger opportunity to evolve or improve air filtration? Bruce, do you want to have a stab at that one in terms of just where you're coming at it from the trends, the environmental issues that are coming forward in terms of air filtration technologies?
Sure, and I'll just maybe pick one or two, because this in and of itself could be an hour-long conversation, I'm sure. I think that going back to sensors, not to overstate the importance, as an industry, since we talk so much about filtration, that's only secondary to knowing and understanding the problem. So I think that potentially standardization around sensors and really understanding the advantages and qualifying the efficacy of sensors and making sure that those are more widely adopted is probably one, if not the most crucial aspect to enhancing higher filtration by drawing people's awareness to the fact that there's a problem. On the filtration side, I would say it's interesting. There seems to be sometimes not correctly so a belief that higher filtration always means low, unbearable pressure drop in a system. So I think that there's an ongoing need. For example, as many of us are aware, the Title 24, I think Part 6 building code in California now mandates that you have to have MERV 13 in all new buildings. That's up from MERV 8 in the past. And we often hear, well, I can't, my system really can't take a MERV 13. I've been using MERV 8. And so again, I think this focus on an education of what is possible for a building to take for the highest filtration that's feasible, and also the continued focus in the industry on getting the lowest pressure drop possible, i.e. getting to a standard MERV 8 pressure drop with a MERV 13 filter or higher, is really the challenge that I think we need to be focused on from an HVAC standpoint. And I would open it up. There's all sorts of other possible products to discuss here.
Okay. Mike, did you have a point on this in terms of the evolving or improvement in air filtration, but also the point Bruce made about sensors as well?
Well, I was just going to take that to the other direction and say, from an evolving air filtration standpoint, we've got something like 3 billion people in the world who live in the hottest parts of the world, less than 10% of whom have air conditioning. And you talk about a very different built environment, and you just don't have a delivery mechanism for filtration the way we do that most of our discussions talking about. So I think, something along the lines of affordable room air cleaners in places that really have a very challenging PM 2.5 environment. In a lot of cases, a lot of times from, burning wood for cooking inside the home. Some of the places here have some of the highest mortality rates in the world because of PM 2.5, and we as a filtration community don't really have a mechanism to address it. So I think that's a huge opportunity and a huge need.
Okay, Kathleen, you've raised your hand as well, and then I'll probably go to Ayad and then the audience, because there's some questions in the audience.
I raised my my hand a while back and just didn't put it down, but
okay.
To me, there's several things. What I think of as in-room air cleaners, but local air cleaners, I think will be a biggie, because as has been mentioned, not everybody has an HVAC, but also even people who do often have sources that are more easily controlled closer to them. Gas phase, as we were discussing earlier, I think is going to be something in a lot of areas. Those are the two. And then it's not technically air filtration, but we have a lot of air cleaners out there right now that are coming on the market that don't technically filter. And it's going to be interesting to see, as we get test methods done, how well they perform and how we can fit them into the IEQ world. assuming that we can.
Thank you, Kathleen. Ayad,
I
yeah,
hope so.
great. Thank you. That'll be very interesting. It is interesting about the gas phase. Yeah, yeah, that's very good point. Yeah, Ayad. Yeah.
Yeah, just very quick points. We still rely on very thin filters and air handling units. This is low efficiency. I don't think we're going to achieve much with 1-inch filter and 2-inch filters. In fan coil units, we have probably 7 mm. I've seen 7 mm thickness filter. This is not going to achieve much. There is a lot of advances in filter media. I know we have a lot of experts today in filter media. We need to have utilization of this. Filter design in terms of cartridges, very conventional, old school, outdated. I think we need to think out of the box, think of innovative designs that will take us from pre-pandemic, ready for the next pandemic, to have no pandemic at all.
Okay. I'll take a few questions that's in the chat. I think one here, I think to highlight the importance of IAQ on health, it's important we should cover the final product standards, close collaboration with IEC, ISO, TC, since there are other regional standard organizations responsible for putting these standards into use on the worldwide basis. Kathleen, this is kind of in your corner. I think we've kind of addressed that a little bit with regard to the standards one in question 2, but maybe just a comment on that. Sorry, you're on mute, Kathleen.
Sorry,
yep.
I couldn't understand the first part of what you said because I don't know what happened, but
I think to highlight the importance of IAQ on health, it's an important topic. Should be covered with the final product standard, i.e., close collaboration with IEC, ISO, TC, ASHRAE, all the standards that exist out there. But I think what they're driving at here is that the regional standard organizations should probably collaborate in order to have.
Yeah.
This is not a local problem; it's a world
you.
problem.
Yeah. I'm hearing 2 pieces in there. One is that we need to get all the different people that are doing testing standards or even application standards to work together. And we are trying. I mean, there's a lot of us sit in committees in more than one group, and ASHRAE has an international standard. We're trying to get things put together. A lot of times, though, we find that an international standard doesn't necessarily do what the American market wants. So sometimes there are reasons that it hasn't happened yet. The other issue is taking those standards and going from cleaning the air to a certain level and making that a health implication. And that's a harder thing to do, because even though we can say that PM 2.5 has issues at certain levels are more likely to cause health issues, we're not then allowed to say that if we reduce the dirtiness in the air by 25%, that we have fix the health by that much. So addressing specifically health issues, I think we're going to have more working like we did during the pandemic, but between the IH folks and the medical folks and the filtration and air cleaning people to get to how do we do specifications to attempt to deal with the health without getting the engineers in trouble for using percent efficiencies instead of a health study.
I'll move on. We've only got about 6 or 7 minutes left, so I'll move on to the number 6. Or we talked a little bit about sensors. Maybe we just come back to that, but I think now we just move on to number 6 in terms of the addressing global water and air problems with emerging filtration solutions. That was brought up quite heavily last week. How do we address global problems with our technologies? Maybe Bob, just to start with a few minutes for you on that. How do you think we address the global problems with our emerging filtration solutions?
My main thought here is that we need to organize the information. It is scattered and disorganized, and the internet has allowed access to prolific information, but in many respects, it's more disorganized and less accessible because of the proliferation. And so I think that is number 1 in terms of communication.
Okay. Bruce, any thoughts on this from you in terms of air and water?
Yeah, I mean, it's a general question. So I would piggyback off of what Bob said. I think it's about, or we have solutions. It goes back to an overarching theme, I think, of this call, which is education, to make sure that the solutions are actually applied. And that's really a larger call, both industry and non-industry, to find a way to simplify and help people understand the importance of solutions to be applied. I might add, and this touches on the last question, I think it connects to this as well, with both water and air problems. I think that we're implying here health issues. And so one thing that seems absent while we have energy calculators and sustainability ways to spit out a number at the end of looking at the the cost of the problem, but health is difficult because there's so many variables, and so we're sort of missing a simple health calculator of here's the inputs, here's the output. And I think until we have that, because a lot of the issues related to both water and air exposure as a problem, they're cumulative. They don't happen overnight. So I think more focus on what the health outputs are, and understanding those to have a clear statement of what you're at risk of if you're not using filtration, and then making sure that we get the right solutions to be applied in the right applications.
Okay. Tyler, did you have any thoughts on this in terms of both air and water, in terms of Johnson Control and where they play a part?
Well, I'll just maybe summarize my thoughts on the last few questions, including this one, as we've got an opportunity to educate. And this group, what WFI is doing, the board here, our members are in a really privileged and advantageous position that we should leverage to educate. And that's why I'm so excited to be a part of this team, because we know a lot. The research community knows a lot. We've learned a lot, especially thanks to COVID. We've got to push that knowledge, that understanding down into the buyers globally, or those who could be impacted by these solutions globally. So that's all I'll add there, Richard.
Okay, no problem. Yeah, Ayad, did you have any thoughts on that, and maybe the last 2 or 3 questions there on this list?
I think, first, I'm happy to launch together with all of you the Filtration Hour. As I said, this is giving the mic or the microphone back to the audience. I've learned so much from all of you, so I anticipate that also the audience has learned as well. I think filtration goes far and beyond in the air quality and the built environment. Also, addressing air quality and air filtration for land-based gas turbine. So I think this is going to be great. This is the first Filtration Hour. We're going to have that hour for weeks to come. But I think we need to alter the way we perceive air filtration. And we need to ensure that filtration has its permanent seat on the built environment, heating, ventilation, and air conditioning, urban design. I think for years, air filtration has been put on the back burner, and the expected fate was the pandemic, where we had to leave what we rendered smart city, built environment, total lockdown. This is the prices we had to pay. Lockdowns, curfews, where we had to abandon the built environment. Again, filtration, is basically the ideal technology that can make us seek refuge in it to make our built environment protected. But, the main point here is we have to grant filtration the attention it deserves.
Okay, that's great. Thank you. We're just about 1 minute away from the end of this. I think the other questions that's been raised, perhaps we can answer them offline, or we can bring them up at the next Filtration Hour. I think what we'll do, Christine, is we'll just bring this to a close now. So I think if you just bring up the last slide, Christine. What we'd like to do is I would like to thank and acknowledge all the the panelists for today. Thank you very much. Thank you very much to the audience for all the questions. I hope you've learned a lot from what you've heard from our panelists, but also from our members. We would also like to acknowledge all these sponsors, and members on board here that's joined us, a lot of new members this year. So without their support, it would not be possible for us to have this filtration hour today. So I'd like to thank you all, wish you all well, thank you for your attention, and hope to see you at the next filtration hour very soon. Okay, thank you everyone, and good day.